Hello and welcome back. Today we have 452 minimum number of arrows to burst balloons. It says here there are some spherical balloons taped onto a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points where each point is the start and end of that stretched out balloon. And we don't care where exactly along the y-axis this balloon is. We do care how long it stretches along the x-axis. And the reason we don't care about the y-axis is the premise is we have some number of arrows which we can shoot up directly vertically. And there is no limit to the number of arrows that can be shot, and each shot will keep traveling up infinitely. So whether a balloon is lower on the y-axis or higher on the y-axis, as long as it crosses the same x-axis, that same balloon will be shot eventually because this arrow keeps on going infinitely and bursts any balloons in its path. Our goal is to return the minimum number of arrows that must be shot to burst all balloons. Okay. Then, given all this, our goal really is to find as many overlaps as possible. And whenever we know that we need to find as many overlaps, the first thing that should come to mind is sorting. So given this input, we have, let's say that's our first input, then we can draw along our x-axis, okay? And this one goes from the largest one is 16. So let's say that we have 0, 5, 10, 15, 20. So let's draw that, 10, 5. Then really the first thing we want to do is sort. And we want to sort by the ends. The reason why we want to sort by the ends is so that we can take advantage of the fact that whatever is ending, in order for there to be a gap and for another arrow to be necessary, whatever the ending value is should not overlap with the beginning of the next arrow or the next balloon. So let's complete this and it will become more evident. So the next one is 2, 8. So this one ends in 6, this one ends in 8. Next one, this one's lower, so 7, 12. 7, 12. And then the last one is 10, 16. Okay, so when we have these guys and it ends like so, we notice that the first balloon, this first guy right here, starts at 1 and ends at 6. The next one, now we know that 6 is our end of the previous balloon. The next starting location is before or equal to, in this case before, it's before the end of the current balloon. So we can actually know for a fact that we can indeed, whatever arrow that shoots this balloon and bursts this balloon can also be used to burst the next balloon, because whatever range there is covered under, so the next balloon start is covered within the range of the previous balloon. So if we have 1 to 6, and this one is 2 to 8. 2 to 8. Let's say that it's 2 to 8. We can essentially shoot anywhere between 2 to 6, but notice that we sorted by the ends for a reason. And that's because essentially whatever the end is would be the optimal place to shoot the arrow so that we can cover as many subsequent balloons as possible. So if we had more than these balloons, and let's say besides 2, 8, we also had maybe a balloon that was going from 3 to 5, and another one that went from, let's say, 6 to 7. As long as the start, this one starts at 3, this one starts at 6, as long as the start is less than or equal to the end of the previous balloon, it can be covered under the same range. Okay, so we have the 1, 6, the 2, 8, the 7, 12. Now the 7, 12 goes from between 6 and 8, 7 to 12, and then 10 to 16. Okay, now the balloon that begins at 7 can't be burst with the same arrow that shoots this balloon because there is a gap, there is no overlap. And if this one is 7 to 12 and this one is 10 to 16, we can see, however, that the end of this balloon is 12 and the beginning of the next balloon is 10, which is before or equal to the end of the previous balloon. So these two can be shot with a single balloon. Okay, so this one we can basically shoot up at we're optimizing by using the last balloon. Whatever the current arrow is, the last furthest rightmost location we can shoot at to cover as many balloons as possible. Since this is already sorted, anything that starts before or equal to the end of the previous balloon will be covered with the same arrow. So one arrow we shoot up here, and then we burst these two balloons. The next arrow we can shoot up here and burst these two balloons, and that way we use exactly 2 balloons. Okay, and to use another example, example 2 is, if you see carefully, there's actually no overlap. So we have one going from 1 to 2, another, this one ends at 2, this one begins at 3, 3 to 4. See, there's no overlaps. Another 5 to 6, 5 to 6, and another from 7 to 8. These are clearly not to scale, but the point being, there's no overlaps. There's no overlap here, 2 to 3, 4 to 5. There's a gap, there's another gap, and hence we need 4 arrows. Okay, however, let's say we modify this so that instead this one 1 to 2, this one began at 2, then this is the shared point. Then we can shoot up 1 arrow here to burst this balloon, and then it was 3 to 4, that's the 1, 2 balloon. So let's say we have a 3 to 4, 3 to 4, and then another one at 4 to 5, then clearly we can shoot up 1 here to cover both balloons. Okay. This is one of those problems where it might actually be clearer just to go to the code. So let's do that. All right. What we did basically was we have some number of points, and the first thing we want to do is sort by the ending location because we want to optimize as fewer arrows to burst as many balloons as possible. So let's do that first, points.sort. And we're going to sort by lambda x, and we want to sort by the end. So that's going to be at 1. Okay, and the other is we're aiming somewhere. And the first point we're going to aim at is the first sorted end. So if this is our end, then that's... Let's do that real quick just to demonstrate. Okay, so this is the sorted version. Then we want to start our aim at the end position of our first balloon. So that's going to be points at 0 and the end position of that. Then we just want to iterate for I in range of 1. We've already done the first one, so let's start from the next one. 1 to the last points. And as long as the beginning of the next balloon is on or before the end of the last aim position, we can essentially continue. Let's see, the shot starts at 1. We need 1 shot to shoot the first guy. And we'll say if the current point at I, if the beginning of that point is less than or equal to our last aim position, then great. It's covered in our current aim within that shot, so it's okay. We can continue. However, once we get to a point where our current point's starting position no longer overlaps with our previously aimed position, then only do we update our aim to the ending position of our current balloon. So aim will be updated to points of where we are currently and to its ending position at 1 index, and we will have to use up another shot. And ultimately, we want to return the total number of shots used up in order to burst all balloons. So submit. Okay, and this is basically 452, minimum number of arrows to burst balloons. The time it takes is n log n because of the sorting. So O of n log n, and the space, let's see, we do this in place, we have some constants, so the space should be O of 1. And again, the main idea is we're using the fact that we can sort by the end location. Then essentially we're just iterating straight and saying whenever the next starting position no longer overlaps with the last ending position, so the last ending position is saved, and we keep iterating. And just like the example, if we have like 5, 6, and let's say 6, 7, all of these would be counted because the start of the next balloon is before the end of the last aim balloon. The start of this one is once again before or at the end of the last aim balloon, and so these would then be able to be shot with the same arrow. Okay, thanks so much. Happy coding. See you next time.